In this screencast, we discuss the topic of order of operations. The example below, example 4.6, motivates this idea. Consider the function given by the equation z equals negative 4v squared plus 1. Let's go ahead and make a flow diagram for this function. First of all, notice that the letter v in the equation is playing the role of the input variable. So I'm going to begin by just writing a v next to the input. The letter z is playing the role of the output, and so I will write a z there. Now, go ahead and pause the recording and see if you can list the operations that go inside this box that enable you to calculate the output. Then continue playing the recording. Okay, your flow diagram should have listed 3 operations. 1, 2, and 3. The 3 operations are multiplying by negative 4, squaring, and adding 1. Those are the 3 operations that are needed to be performed in order to produce the outputs of this function. What order did you list these operations in? Does it matter? Well, suppose you were going to evaluate this function when v was 2. In other words, suppose you were going to substitute the number 2 into this function. Depending on the order in which you listed these 3 operations, you could arrive at an output value of 65 or negative 15 or 49 or possibly some other value. So the order in which you list these operations affects the output of the function. So the order really does matter. Whenever we write mathematics, it's essential that we write it in a way that clearly communicates our intentions. To this end, we've universally agreed on rules for writing and interpreting mathematics, so that when multiple people are all looking at the same equation, everyone will interpret the equation in exactly the same way. These rules are referred to as the order of operations, and they are summarized in the box below. When interpreting a mathematical expression or an equation that involves multiple operations, that's the key here. These operations are assumed to be performed in the following order. First of all, any operation within a grouping symbol is assumed to be performed first. Grouping symbols include parentheses, brackets, braces, radical symbols, and division bars. Second, any required exponentiation is done next. Exponentiation just means raising numbers to powers. Third, perform any multiplications or divisions, and we do them left to right. Fourth, perform any additions or subtractions that need to be done, and these are done left to right in the expression or equation. So, using the order of operations, how should this equation be interpreted? Well, let's start with number 1. There are no grouping symbols in this equation, so we can skip number 1. Then we proceed to number 2. We perform any exponentiation. Well, in this equation, squaring has to be done. That's raising v to the second power. That is the first operation that is to be performed. So in your flow diagram, under number 1, if you listed squaring, you would have been correct. Next, let's move to 3. Perform any required multiplications and divisions, left to right. Well, in this equation, there's one multiplication to perform, namely multiplying by -4. So that's the second operation to be performed in the flow diagram. Now we perform any additions or subtractions left to right. In this equation, there's one addition to perform, namely adding 1. So that is the third operation in the flow diagram. So if you were going to evaluate this function at v equals 2, in other words, you were going to substitute the number 2 into this function, you would have found that the resulting output value was -15. In the next 3 examples, you will practice working with these order of operations. Okay, before jumping into example 4.7, I want to take a moment and talk about a technical point that sometimes confuses students. I'll do this down below here. I'm going to write down the following 2 expressions. If you look at these 2 expressions, the only difference between the 2 is that the top one has parentheses and the bottom one does not. You might think that the presence of the parentheses here doesn't matter, but in fact, with the parentheses, we interpret this expression differently than we interpret the bottom expression. With the parentheses, we interpret the top expression as -3 times -3. In other words, -3 is being squared, which gives us an answer of 9. So the squaring is applied to the number -3. Without the parentheses, the quantity being squared is just the 3. So we interpret this as negative, and now I'll insert some parentheses, 3 times 3, or 3 squared. This gives us a -9 when we simplify. So notice the presence of the parentheses affects the final answers. So you cannot simply ignore the parentheses. If ever you are squaring a negative number, you need to write the expression this way. The negative number needs to be in parentheses if you are planning to square it. Okay, now that we've discussed that technical point, let's go up and look at example 4.7. Evaluate the function given by the equation a equals t squared minus 3t plus 1 at the following values of t. So in part A, we're evaluating this function at t equals 4. In other words, we're substituting 4 into this function in place of t. So I'm going to begin by inserting 4 in all places involving t. The function begins by squaring t. So I square 4. And then I subtract 3 times t, which would be 3 times 4. And then I add 1. Now I have to simplify this expression in order to determine the output of this function. This is where order of operations comes in. In order to simplify this, there are several operations that have to be performed, and we need to make sure we perform them in the correct order. There are parentheses in this expression. The 4 is inside the parentheses. There is no operation that is to be performed inside the parentheses, however, and so we can skip step 1. So we proceed to step 2 in order of operations. That's the squaring step. We do have to square 4, so that's where we begin. Squaring 4 gives us 16, and then we still have to perform the other operations. Next, we go to step 3 in the order of operations. We perform any multiplications or divisions left to right. There's only one multiplication to perform. We have to multiply the 3 and the 4. So we have 16 minus 12 plus 1. And lastly, we perform any additions or subtractions left to right. Since we're doing this left to right, we start by doing the subtraction, 16 minus 12. That gives us 4, and then we have to add 1 to that. That's the last step. And we arrive at 5. So when we evaluate this function at t equals 4, we arrive at an output of 5. Now let's look at part B. Now we're evaluating the function at t equals negative 4. So we begin by replacing t with negative 4 in the function. The first thing that's done to t is squaring it. So we are squaring negative 4. Recall the lesson we learned down here. Whenever you square a negative number, you have to put the negative number in parentheses. So here we write this as negative 4 in parentheses squared, and this will remind us that it's negative 4 that we're squaring. Minus 3 times t, but t is negative 4, and then we add 1. Again, we use order of operations to simplify. We begin with the squaring. Negative 4 squared, that's negative 4 times negative 4, that's 16, minus 3 times negative 4 plus 1. Next we perform the multiplication. This would be 3 times negative 4, that's negative 12. So we have 16 minus a negative 12 plus 1. Next, we perform additions and subtractions left to right. Starting on the left, we have 16 minus a negative 12. That's the same as 16 plus 12, which is 28. And then we add 1. When we add 1, we arrive at 29. So when we evaluate this function at negative 4, we arrive at an output of 29. Now let's look at example 4.8. Evaluate this function given by the equation y equals negative x to the 4th at x equals negative 1. Notice that the letter x is playing the role of the input variable and the letter y is playing the role of the output variable. Before substituting negative 1 into this function, let's take a moment and make sure we know how to interpret the right-hand side of this equation correctly. Negative x to the 4th. What exactly is being raised to the 4th power here? Is x being raised to the 4th power, or is negative x being raised to the 4th power? Remember what you learned down here. In order to raise a negative quantity to a power, you write the negative quantity in parentheses. Notice that there are no parentheses here. Therefore, the only quantity that is being raised to the 4th power is x by itself. So, with that in mind, let's go ahead and evaluate this function at negative 1. I substitute negative 1 into the equation. X is replaced with negative 1. X is raised to the 4th power. So we are raising negative 1 to the 4th power. In order to do that, I have to put the negative 1 in parentheses. Out in front, I still have the negative from the original function. So this negative is this negative. X is negative 1, and I'm taking negative 1 and I'm raising it to the 4th power. Now let's simplify. We use order of operations to simplify this expression. There are parentheses here, but there are no operations to perform inside the parentheses. So we proceed to exponentiation. -1 is raised to the 4th power. That means we're multiplying -1 by itself 4 times. If you calculate this, you arrive at the numerical value of 1. So this quantity just itself right there is 1. And then there's a minus in front of it, which means we arrive at an answer of -1. So when we evaluate this function at x equals -1, we arrive at an output of y equals -1. In this last example, each of the functions is represented by a flow diagram. Let's write each of the functions as equations, and in each case we'll use the letter u to represent the independent variable, or the input, and the letter v to represent the dependent variable, or the output. So let's look at part A. So the input is represented by the letter u, the output is represented by the letter v. Okay, this function begins with u. That's our input. What's the first thing that happens to u? We add 2 to it. So I take u and I add 2. The next thing that happens is we are supposed to divide this quantity by 4. So I take my u plus 2 and I divide it by 4. The last thing that happens to the quantity is we square. So I'm taking my entire quantity, the entire quantity here, and squaring it. In order to make it clear that I'm squaring the entire quantity, I put that quantity in parentheses, as such. This should give me my output, which is v. Now let's check to make sure that the way we've written this function conveys these steps. So suppose we were going to evaluate this function at a particular number. So we would take that number and we would insert it here for u. So imagine we were substituting a number in for u. If we were going to calculate the output, we would use our order of operations to do that. So if I was going to simplify this, I look inside the parentheses first. So I have to perform these operations. Now the division bar is a grouping symbol. Operations above and below the grouping bar, above and below the division bar are assumed to be done first. There's only one operation to perform above the division bar, so that happens first. So the very first operation here is adding 2. Once that's done, we divide by 4, and then the operations inside the parentheses are done. So we've dealt with operation 1 and operation 2. Then we do the squaring afterward, which is what we were supposed to do third. Now let's look at part B. Again, we're starting with an input of u and we are arriving at an output of v. Let's begin with u. The first thing that has to happen to u is we have to multiply it by -2. That will give us -2u. We have to raise this quantity to the 4th power. Now to make it clear that we're raising this entire quantity to the 4th power, I'm going to enclose it in parentheses. The third thing that has to be done is we subtract 3 from our quantity. So I subtract 3. This gives us our output. Again, let's check to make sure that the way we've written this equation conveys this order in which the operations are supposed to be performed in this function. So imagine we were going to evaluate this function at a particular number. So we're substituting some number in place of u. If we were going to calculate the output, we would follow order of operations to do that. So what would we do first? So we're putting a number in place of u. What do we do next? Well, we have grouping symbols here, parentheses, so we're obligated to perform the operations in the parentheses first. That means we have to multiply by 2 first. So that agrees with how we wrote this in the flow diagram. Once the multiplication by 2 is performed, we've done the operation inside the parentheses. Order of operations says we perform exponentiation next. So the raising to the 4th power would happen next, and that agrees with the listing of step 2. Once that's done, we perform any multiplications or divisions. There are no other multiplications or divisions to perform. There's only one subtraction to perform. We have to subtract 3, and that's the third thing listed in the flow diagram.